So today you're going to learn how to graph, stretch, compress, reflect, and translate sine graphs. In order to do today's lesson, you have to be familiar with SOHCAHTOA. So quickly to review, SOHCAHTOA. So this means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And of course, that pertains to the reference angle. Also, you need to be able to identify your 45, 45, 90. So we did that. So that's 45, 45, 90. And hopefully you remember that anything opposite of 90-degree angle, it's 1. 45 is radical 2 over 2, radical 2 over 2. And then we also have 30, 60, 90 memorized. And 30, 60, 90 is opposite of 90 is 1. Opposite of 30 is 1/2. And opposite of 60 is radical 3 over 2. You have to have those degrees memorized. You have to be familiar with SOHCAHTOA. And you absolutely have to be able to create the unit circle from scratch. If you are a little rusty on the unit circle, this is the time to quickly review it, because you won't be able to do this lesson without it. We are going to start by filling the table by using the unit circle. So we are going to start with the first degree. Notice, I want to get your attention that sine of theta of the angle is represented by your y. So if I'm looking at 0 degrees, my coordinate is on a unit circle is 1, 0, which means it's 0. If I'm going to the pi, which is 180 degrees, my coordinate is negative 1, 0. That means my coordinate on y is 0. And then if I go to 2 pi, which is same as 360, all the way around, again, I get 1, 0, which is 0. So we did those. So let's go halfway through. So now I have pi over 2. So pi over 2 is 0, 1. So in this case, my 90 degrees is 1. If I go to 3 pi over 2, it's 0, negative 1. So that's negative 1. If I go to 45 degrees, so if you visualize this being a triangle, 45, 45, 90, this is my 90 degree. So this is going to be 1, and this is going to be a radical 2 over 2, and this is your radical 2 over 2. So this is where that knowledge of that triangle comes into place. So if I'm looking the coordinate, notice is radical 2 over 2. So 45 degrees is radical 2 over 2, or mathematically it's 0.7. 3 pi over 4, so it's right here. That's negative radical 2 over 2 and radical 2 over 2. So that's again radical 2 over 2, or 0.7. 5 pi over 4. It's over here, and notice that it's a negative radical 2 over 2 and negative radical 2. So it's a negative radical 2 over 2, or negative 0.7. And the last one is 7 pi over 4, which is radical 2 over 2 and negative. So it's negative radical 2 over 2, or negative 0.7. So we completed the table, and now we are going to graph. The first thing we are going to start with 0, 0. And we're going to label. So this is going to be my 1. And this is going to be my negative 1. I'm going to label my x coordinates, and notice that it goes 0, pi, 4, pi over 2, 3 pi over 4, and so on. So I'm just going to label it, go by 4. In sine, it's very helpful if you scale your graph, and you always scale by 4, and I'll show you in a moment why. So this would be my pi over 2. This would just be my pi. This would be my 3 pi over 2. And this would be my 4 pi over 2, or just 2 pi. Okay? So I'm going to stop here, because Sinus function is cyclical function, goes into infinity. But for our purposes, when you graph on a test and on the homework, it's sufficient if you just graph the period. So I'm going to graph the period first, and excuse me, and then I'm going to show you how it continues on. So the first thing, I'm going to graph my zeros. So 0, 0 is my starting point. At pi, my coordinate is 0. So this is the middle, it's 0. And then I have 2 pi, that's another one, is 0. So I'm going to put 0 there. So I'm going to use red. So this is my 0, this is my 0, and this is my 0. Pi over 2 is positive 1. So this is going to be my point there. And 3 pi over 2 is negative 1. So that's, remember how I said at the beginning, it's very helpful if you scale it by 4, because I have halfway through. It's going to be on the midline, what we call, and then halfway is going to be positive and negative. Now we're going to connect, and you're going to curve. Please do not graph as a V. Some of you just go up and down. That's not the correct function. It has to be curved. So here's your, what we call a period. This period goes from 0 to 2 pi, so we call this period. This is your period, and it's 2 pi. Period. Now, you also have to know that this continues. So 1, 2, 3, 4, this would be your negative pi. 1, 2, 3, 4, this would be your 3 pi. 1, 2, 3, 4, 4 pi. 1, 2, 3, 4, 5 pi. So if I technically, I can continue. So this is next cycle is going to be, this is 1, 2, 3. And then halfway up, halfway down. So here as I continue on. And then here again, I would continue halfway, it would go up, come down, and this would continue. And same on the opposite end, I think halfway is down, and so I would go down, curve, and this one goes into infinity. So for our purposes, it's sufficient that you draw one period graph. So what you need to know is that, notice that if I have to draw the line through the middle, this would cut my graph exactly in half. So this is exactly what we have. This is called midline. It cuts your graph exactly in half. And this part here, I don't know how I should do it. I don't know what I should do. It doesn't matter where I do it. Here goes from midline to, it's called amplitude. Okay, so if you want to kind of look here to here, this is your A. This is your amplitude. Okay, so let's talk about the graph. First of all, I want you to notice that it goes into infinity. So your domain is open brackets, negative infinity to positive infinity. Range is somewhat limited. It goes from positive 1 down to negative 1. So it's a closed brackets. It goes negative 1 and a positive 1. Okay, functions that behave in such a repetitive or cyclical manner are called periodic, which makes sense because they just kind of periodically repeat and continue on. Period is the length of one cycle. So one cycle represents period and determines how many radians it takes before the sine curve repeats. So if we look at this function, my sine function, my period in this example is 2 pi. Amplitude is the height of the wave from the midline. Okay, that's important. Height of the wave from the midline. And so in this case, the midline is the x-axis, and amplitude in this case is 1, because we go from midline to the top of the wave, which is 1, positive 1. Okay. Also, what you need to know, amplitude is always positive. Okay, always always positive. Tells you how high you go. Okay, today we will practice graphing and writing the equations for the sine function. So the first thing we're going to talk about the function a, b, c, and d. Notice that a is located in front of the sign, b is attached to x minus c plus d. So this is same as hk. The c is going to be always opposite, and k is outside. It's going to be the same. So inside parentheses opposite, and d is going to be the same. So the first I'm going to give you the steps for graphing, and then I'm going to give you steps for writing the equation. So steps for graph. First thing you're going to do is you're going to find amplitude. And that's going to be the absolute value. And you're going to find period. And the way you find the period, you use the formula. Your formula is 2 pi over absolute value of b. You have to know this. This is your formula for the period. Okay? And then this is amplitude. So you're going to find the period. You're going to find your amplitude first. Then you find the reference point. So you're going to find the reference point, and the way you find the reference point, you solve bx minus c equals to 0, and what are you going to solve for? You're going to solve for x. Okay, so that's how you're going to find the reference point. So you're going to find the reference point, and you're going to solve bx minus c. You're going to make it equal to 0. Then you're going to label axis to fit graph. Basically, you need to take into consideration reference point plus period. Like, you need to make sure that it fits. Then you're going to plot reference point you're going to plot reference point and cycle endpoint. Basically, you need to know where does your period end. So that's going to be your endpoint. And then you're going to plot points in between. And you're going to draw the curve. I have say curve because, again, some of you just draw the V, the straight lines, and then you get letter V, which is absolutely incorrect. So that would be wrong. Anytime you graph, you need to make sure you curve. So those are the steps for graphing. And now I'm going to give you the steps for writing the equation, and then we're going to go to practice. So how do we write an equation? You need to first identify the midline. And basically, D is going to give you a chance to identify the midline. So you want to identify the midline to find A. Okay. So you need to find A first. Okay. Then you're going to identify reference point. HK. And you're going to identify period to solve for B. And you're going to plug in I'm sorry, you're going to plug in A, B, H, and K into the equation, which is going to be y is equal to A sine B parentheses x minus h plus k. Okay, x minus h plus k. So you're going to plug it into this equation, but you're not done because you always want to end with distributing b. And so your final product is going to be y is equal to a sine of parentheses bx minus bh plus k. So that is going to be your final. Okay? So, a lot of steps. So let's see if I can simplify them for you. And again, we'll start with graphing and then we'll slowly go into writing equation. Hopefully that will be helpful. Before I start graphing, I want to quickly review, point out that you have 3 points that are on the axis. So this is the beginning, this is the end of the period. So the beginning starts at my reference point, and you have 3 points on the midline. Halfway, so 1/4 of the way, you're going to go on amplitude up. 1/4 of the way, you're going to the amplitude down, and you connect the dots and curve. So let's get started. So the first example, let's see, make sure you can see the equation. Okay, y is 3 sine of 2x. First thing, you need to find the amplitude. Notice amplitude is letter A that's located in front of sine, so there's no calculation. In this case, amplitude is 3. Okay, this is your A. Your period is equation, which is 2 pi over absolute value of b. In this case, b is the number in front of x, so this is your b. So this would be 2 pi over 2, and 2's cancel, so my period is a pi. So the next thing I'm going to do is I need to find reference point. And to find the reference point, you put bx minus c equals to 0. But in this case, I don't have anything attached to 2x, so it's just going to be 2x equals to 0. If I solve for x, so x is equal to 0. I don't have any number besides 2x, so my reference point is just 0, 0. So how do you graph? You start at your reference point. This is my 0, 0. My midline is this y, which is 0. So in this case, this is going to be my midline. I know the right on x-axis. My amplitude is 3. So in order for me to fit, you can scale any way you want. The only requirement is that it fits on your graph. So in this case, this is going to be 1, 2, 3. This is positive 3. 1, 2, 3. This is negative 3. So this is going to be my amplitude. And my period is pi. So I remember how I told you we can count by 4s. But in this case, in order to, to scale, I'm going to count by 4. So it's going to be 1, 1, 2. This is going to be my 1, 2, this is going to be my pi over 2. I'm going to stretch it out a little bit just to make it bigger. But I could have technically counted this as my pi 2, and then it's just going to be narrower, but I just kind of chose to stretch it. You can scale it any way you want. So 1, 2, 3, 4. So here is my pi. So one more time. I could have counted this as my pi over 2, and this is my pi. And then my graph would just kind of be up to here, but I just chose to stretch it out a little bit more, so scale it a little bit different. So again, you can scale it any way you want. The only requirement is that I can see it, how you scaled it, and that everything fits nicely on your graph. So just like here, going back to my original graph, I have beginning on the midline, end of midline, and middle of end line. So we're going to midline. So we're going to do that first. Okay. So I'm going to have beginning, end, and middle. So here are my 3 points, right, on midline. And then halfway between the midline and origin, I have up to amplitude. Halfway, I go down to amplitude. So in this case, 3 is my amplitude. So here is going to be my point up. And then halfway is going to be -3. Here is going to be my 3 down. So all I have left now is to curve. So curve nicely and go. So I don't have to technically graph further as long as you tell me that this graph would continue, because it's a continuous graph when you're done. Okay, let's look at the next one. The next one, and notice it has something important in front. It has a negative. So what does negative usually mean in front? That means usually reflection. Okay, so if I reflect, that means it's going to be opposite. Hopefully you can anticipate that. My amplitude is not -2. Remember, amplitude has to be always positive, so my amplitude, it'll just stay 1/2. My period, I'm going to calculate, so it's going to be 2 pi over b, and in this case, my b is 3, so it's going to be 2 pi over 3. So my period is 2 pi over 3. I need to find my reference point. And so that's going to be 3x equals to 0. X is equal to 0. Nothing after the 3x. So my reference point is going to be 0, 0. Okay, 0, 0. So let's start. Reference point is 0, 0. My midline, again, it's just going to be in the middle. My period is 2 pi over 3. Now remember what I said. We always want to count by 4s because that's easier how to plot the sine function. So 2 pi over 3. So I'm going to count 1, 2. This is going to be my pi over 3. And then 1, 2. And it's going to be 2 pi over 3. Okay. My amplitude is 1/2, so I'm just going to label this as 1/2. Technically, I could label this as 1/2, whatever works. The only reason I'm saying don't make it too small, because I got to be able to see all your points. So this would make it -1/2. So beginning, middle, and end. Okay, so we got those. Now be careful. Instead of going up, where am I going to go? Down. Why? Because this is a reflection. So now it's going to be down, curve, up, curve, down. So it's going to be arrow and arrow. So to label from here to here is my 2 pi over 3 period. And here is my amplitude of 1/2. Okay, so I need to be able to see that, and you should always label it so you don't make a mistake. So here, from here to here is my period pi, and from here to here is my amplitude, which is 3. Okay, let's go on, see if we can make it a little bit more fun. So I'll go to the back side. So the first thing, notice that you have amplitude is, oops, you can't even see, sorry about that. You have amplitude is 1/2. My period is, and this is invisible 1 here in front, so it's going to be 2 pi over 1, or so my period is just going to be 2 pi. My reference point is going to be, now notice I have x minus pi. I'm going to make it equal to 0. So you're going to add pi to both sides. X is equal to pi. But because I don't have anything else after that, so my reference point is going to be pi, comma, 0. So my midline is going to be 0. So this is going to be my midline again. Okay, my midline. My amplitude is 1/2, so let's just label this 1/2. This is going to be negative 1/2. Now notice my period is 2 pi, but I need to start at my reference point. So you always want to start at your reference point first. So my reference point is pi or pi 0. So this is, I have enough room, I can count by 4. So 1, 2, 3, 4, this is my pi. 1, 2, 3, 4, this is my 2 pi. 1, 2, 3, 4, this is my 3 pi. So my period is 2 pi, but it starts at pi 0. So this is my beginning. And from here, I gotta count 2 pi's for my period. So again, everything else is the same. 3 points. And then this is positive, so it's going to go halfway, you go up. Halfway, you go down. And then you just curve and connect and put arrows at the end. And you're done. Okay? This is period, and this is amplitude of 1/2. Going to the next one. Notice in the next one, I have a negative again. So I don't know how you want to remind yourself that you reflect or something that you remember this on the test so you don't make a silly mistake. So the first thing you notice, my amplitude is 3. My period is going to be, it's going to be 2 pi. Now what's invisible in front of x again? 1. So it's going to be 2 pi over 1. So it's going to be just 2 pi again. And my reference point, it's going to be x minus pi over 4 equals to 0. So if I want to solve for x, you're going to add pi over 4 to both sides. So x is equal to pi over 4. So pi over 4 is my x coordinate, but notice that I have here plus 1. That's going to be your midline, and that's going to be your y coordinate. So midline is y is equal to 1. So this one is a little bit trickier. So y is equal to 1. Let's see, amplitude is 3, so we'll just count them by 1. So this is 1, 2, 3. My midline is right here at 1. My reference point is pi over 4. So I am going to start at pi over 4. So this is pi over 4. Okay. So think about it. Pi over 4. So I'm just going to go. So this is 1, 2, 3, 4. So this is your pi. 1, 2, 3, 4. This is your 2 pi. Right? Now, I'm not starting at 0, 0. I'm starting at pi over 4. So that's going to end, my whole period, that is 2 pi, is going to end at 2 pi and 1/4. So it's going to end right here. So this is pi over 4, so that everything is shifted 1/4. So my period is, so pi over 4 is my beginning, 1/4 after 2 pi, and this is halfway. Okay, it is negative, so that means now amplitude is 3. So I'm going to label, this is going to be my -1, it's going to be -2 and -3. So here you have to be careful. Okay, this is going to be my 4. Okay, so this is my reference point, no longer on the x-axis, it is on the midline. So this is my 1 point, here is my middle, and then here is my end. Remember, it has to be on the midline. Now, halfway, it's going to be my, now I need to, instead of up 3, I'm going to go down 3. So 1, 2, 3. And then halfway, I'm going to go 1, 2, 3 up. So you go down curve, up curve, and that's your graph, understanding that this continues. So your amplitude, this is your A, and your period is 2 pi. So one more time, my reference point is pi over 4 and 1. So 1 is your midline. This cuts my sine function in half. I no longer start in origin. I started pi over 4 and 1. So here, pi over 4, that means 2 pi is going to be shifted 1/4 to the right of 2 pi. And again, I have my 3 middle and 2 ends on midline. And then halfway, I'm going to go down this time because it's a reflection. Halfway, I'm going to go up. And you got to count 1, 2, 3 from the midline. Okay, from the midline. Okay, let's do 2 more. The next one is a graph. It's a positive, so its amplitude is 1/2. This time the period we need to calculate, so it's going to be 2 pi over b, which in this case my b is 2. So it's going to be 2 pi over 2, so my period is just pi. My reference point, so I'm going to call this reference point. It's going to be, notice I have to now write, I have 2x plus pi, so it's going to be 2x plus pi equals to 0. So 2x equals negative pi, and then I have to divide by 2, so x is equal to negative pi over 2. That is your x, okay? Now, notice who do I have here at the end? Your y is, this is your k, this is your y, is negative 3 over 2. So, my reference point, it's going to be, in this case, negative pi over 2, comma, negative 3 over 2, okay? Negative 3 over 2. So this one's going to be a little bit trickier. And so first of all, we need to decide my scale. And I am going to count by 1. So let's just do 0, 0, negative 1, negative 2, negative 3. And this is positive 1, positive 2, and positive 3. And my period starts at negative pi over 2. So I'm going to count by 2. So this is my negative pi over 2. This is 0. This is positive pi over 2. So the first thing is it's negative pi and negative 3/2. So negative 3/2, it's 1.5, so it's a halfway. So my midline is between negative 1 and negative 2. That's my midline. So negative pi over 2 and negative 3/2. So this is my starting point. This is my reference point. My period is a pi, so this is a half a pi, another half of the pi, so that means I end here, and then this is halfway. And it's a positive, and it's going to go half. So in this case, I'm going to go half up, which ends here, and I'm going to go half down, which ends here. So I should have probably done a better job of scaling this, but it's okay. As long as you can see that my period is from, this is my pi period, and then from here to here is your A, which is 1/2. See, this is what happens when you scale very small. It's a very small graph. It's sometimes hard to see. I could have technically scaled by 2, and then I would be able to easier fit everything. But just make sure that you can clearly label and that you're correct on labeling the midline and so forth. Okay, one more time. -3/2 is your midline. So whatever is attached, that's your K, that mirrors the midline. Okay, last graph, and then we're going to go to the equation. So the graph A, amplitude is 2, period is, now be careful, what's in front of X? Okay, everything that's in front of X is your B. So in this case, I'm going to find my period. It's 2 pi over B, which is 2 pi over 2 pi. Well, what happens? 2 pi over 2 pi is just 1. And then I'm going to find my reference, which is going to be 2 pi x minus pi equals to 0. So the first thing, you need to add pi to both sides. So you have 2 pi x equals 2 pi. And now I need to divide everything by what? 2 pi. So you have x is equal to pi over 2 pi. And what can you cancel? You can cancel the pi's, and on top you have 1. So x is equal to 1/2. So your reference point is 1/2 is your x, and y is this -1. So your reference point is 1/2 and -1, which means right away your midline is at -1. So if I'm scaling, I'm going to start scaling by 1. So this is -1. -2, +1, +2, and I'm going to, -1 is my midline, so this is my midline reference, and notice that my period right now, it does not have a pi, so that means when I'm labeling, I am going to label clearly each one. Now, there's no pi attached, so I'm going to label, this is going to be my 1/2. This is going to be 1. This is going to be 3/2. And this is going to be 2. That should be sufficient. So my graph is 1/2 -1. So this is my first reference point. My period is 1. So 1/2 to 1 is 1/2, and then to 3/2 is 1. So here is my end, here is my middle, okay? My amplitude is 2. So I am at -1, so -1, so this is 1 and this is 2. And then halfway I go 1 and I go 2 from the midline. So you are at -3 here. So one more time. So this goes up curves, down curves. It goes this way. Okay. So my period is 1/2 to 3/2. So the period is just 1. And my amplitude from here to here is 2. Okay, amplitude is 2. Okay, let's see if we can now write the equations. So before I go into writing equations, I'm going to quickly review the steps. So the first thing is you're going to identify the midline to find A. You're going to identify the reference point, HK. You're going to identify the period to solve for B, plug in ABHK, and then you're going to distribute the B. So let's look at our graphs. Okay, So the first thing is notice that you have a graph and you need to identify the midline. So by looking at the graph, you notice that this is bottom, this is the top. So the midline, if I'm eyeballing it from here down to here, would be 2. So 2 is your midline. So I'm going to draw the dotted line so I can visually see that this is my midline. Okay, so by identifying the midline, that allows me to see what my reference point is. So I can clearly see this should be my reference point. And because I'm talking about the period, go up, down, and this is where I end. I end at this point here. So the first thing I'm going to identify is my period. So half, this is 1 pi, a half, and this is 2 pi. So my period really represents 2 pi. So my period is 2 pi, okay? The other thing is we need to identify the amplitude. So the amplitude would be from my reference. So this would be 1, 2, 3. So A equals to 3. My period is 2 pi, and my reference point is negative pi over 2, comma 2. Okay, negative pi over 2, comma 2. So now I need to find my period. This is a little tricky, so we're going to go backwards. So you know that period equals to 2 pi over b. Well, we found the period. What was your period? 2 pi. So I can put 2 pi equals to 2 pi over b. And so you have to solve for b. And so the easiest thing is you can do it as a proportion where you multiply across, or you can just kind of say, oh, I need to get rid of the b, so you're going to multiply both sides by b. So then you have b times 2 pi equals to 2 pi. And then to get rid of the 2 pi, you divide by 2 pi, and so you get b is equal to 1. So now that you have everything, you are putting it into this equation. Y is equal to a sine of b, parentheses, x minus h plus k. Remember, h is inside the parentheses, so what operation it's going to be? It's going to be opposite. So make sure that you're careful with that, and then you'll pay attention to details. So let's see if we can put it back in. So y is equal to a is 3. So 3 sine, okay, in b is 1, so it's going to be invisible 1. I don't necessarily have to put it there, but just as long as you understand it's there. X, now, negative pi over 2, it's going, this is hk. Okay, so h is always opposite. So if this is minus pi over 2, what is this going to be? Plus pi over 2. And this is going to be the same case, the same, plus 2. Okay, so 3 sine 1 times x plus pi over 2 plus 2. Now, I don't have to multiply by 1 because it's 1. So there's no need to distribute here. Okay, okay, let's look at the next one. The first thing is you're going to look and see if we can identify the amplitude. What is the halfway? So if we kind of look from here to here, where would be the halfway? And hopefully you can realize that a halfway would be your axis. And so in this case, we're going to start right here. Usually, sometimes students go, wait a minute, when it's positive, when it's negative, technically it's the same thing. It just depends where you start your period. Usually we start close to the axis, and that's where we usually start the measurement. So in this case, if I start here, so you go down, you go up, and so I stop right here. So my period would be from negative pi all the way to 3 pi. So that would make your period 4 pi. Okay, so 4 pi is your period. The next thing is we're going to look and see if we can identify your amplitude. Hopefully you can identify that easily. So from here to here, so A is equal to 3. The next thing is you're going to identify your reference point. So your reference point is negative pi, comma, 0. And so now we need to find your B. So my 4 pi equals to 2 pi over B. So again, I multiply by B both sides. So I have B times 4 pi equals to 2 pi. Divide by 4 pi's. B is equal to 2 divided by 4 is 1/2. B's cancel, so B is equal to 1/2. So now that I have B, I'm going to put it all together. And so y is equal to, now I also have to pay attention because I'm going to go down, up, and up. So that means A is going to be negative. So I'm going to write y is equal to negative 3. So negative 3 sine, it's going to be 1/2 x, this is minus pi, so it's going to be 1/2 x plus pi, right? And k is 0, so I don't have to write k. So the last thing you have to do before for your answer is you would have to distribute this to everything. So your final answer is going to be y is equal to negative 3 sine 1/2 x plus pi over 2. Because you distributed that 1/2 to everything in parentheses. Okay? So that's the end. Okay, moving on, last two. So let's see if we can first identify the midline and the period and the reference point. So hopefully you already noticed that this is also going to be negative. So let's see. My midline is going to be, so if I'm looking from here to here, it's a 5. So and then it goes up to 1, so it's really 6. So you are going to go to 2, right? So 1, 2, 3, 1, 2, 3. So my midline is at negative 2. So negative 2 is your midline. Always double check. Do you have the same amount above as you have below? So A in this case is equal to 3. And now that I'm going to identify my reference points. So this is my reference point. And then I go down, up, over. So this is my end of my period. So from negative pi over 2 to 3 pi over 2. So this is half, 1, 1.5, 2. So my period is 2 pi. Okay, my period is 2 pi. Hopefully you see that I started, and I'm kind of going this way. Okay, you will get the same answer if you start your, but you have to know that you're starting, your reference point is always on the midline. Okay, so and in this case I chose to start here, so it's negative. I could have chose here and then it would be positive. So it repeats, so it's absolutely okay. So the next thing is we are going to find the B. So 2 pi equals to 2 pi over B. Again, multiply both sides by B. So B times 2 pi equals to 2 pi. 2 pi divided by both sides, you get B is equal to 1. So in this case, there's not much work because you won't have anything to distribute. So y is equal to negative, right? Because you went down. So negative 3 sine parenthesis. Oh, I didn't write the reference point. So my reference point is negative pi over 2, comma, what is your y? Negative 2. So it's going to be x plus pi over 2. And this is your h, this is your k, so this is going to be minus 2 at the end. So this is your equation. And last one, yay! Okay, so for the last one, let's see if we can identify where is the midline first. So notice this is 2, this is 2. So my midline would be right in on axis. And so now I'm going to identify, I'm going to start here. And so I'm going to go up, down, over, and I'm going to stop here. And so I start at -1 and add, so that's 1, 2, 3, 4. So my period is 4. No, notice that there's no pi's. And then your amplitude is 2. And your reference point is -1, 0. So now we're going to find the b. So 4 is equal to 2 pi over b. Multiply both sides by b. So b times 4 equals to 2 pi. Divide by 4, and b is equal to 1/2 pi. 1/2 pi. So now I'm going to have to put it all together. So y is equal to a is 2 sine b is 1/2 pi, so it's going to be 1/2 pi parenthesis. It's not going to be x minus 1, it's going to be what? X plus 1. Now, why is this not my final answer? What do I still have to do? Hopefully you realize that you still have to distribute. So your final answer is going to be y is equal to 2 sine, okay? Now, I'm going to distribute, so it's going to be, you can write pi over 2 or 1 pi over 2, it doesn't really matter, 1/2 pi or just pi over 2x plus pi over 2, or 1/2 pi means the same thing. And because k is 0, you are not adding here. You don't have to put plus 0. This is kind of silly. Okay, that's it. Thanks for listening. If you need to watch it again or review something, please do. Homework is on the worksheet. Good luck, guys.